Hey guys, welcome to Infinity Coaching. Today I've got a great topic for us to discuss. It's antibodies. If you're preparing for GPAT, NIPER or similar competitive examinations, then this video is for you. Even if you're preparing for your university exams, trust me, there's something good in this video for you guys too. So sit back, watch the video till the end. We might just learn something good today. So let's begin by answering a very simple question. What are antibodies? Simply put, antibodies are globular proteins that are made exclusively by immune cells, and hence they are also known as immunoglobulins. You see, our body has so many different types of proteins that fold into so many different types of shapes. The two most common three-dimensional shapes into which the proteins fold are a spherical shape and a fibrous shape. Accordingly, the proteins can be classified either as globular proteins, the proteins that fold into a sphere, and fibrous proteins that fold into a fibrous structure. Guess to which class do antibodies belong? You guessed it, antibodies belong to the globular type of proteins. Okay, so antibodies are globular proteins, but we have to understand that not all globular proteins are antibodies, but all antibodies are globular proteins. So now that we know what they are, where are they present in the body? Antibodies are present in both blood, that is the plasma of the blood, as well as tissue fluids. You see, if we try to separate the proteins present in the plasma, we end up with a curve looking something like this. Here you can see two distinct shapes. One is for a protein known as albumin, and the other section is there for a protein known as globulin. Now, it is interesting to note that both albumin and globulin are globular proteins, but they have different molecular masses. Not only that, but globulins themselves are not homogeneous. They have different types. For instance, the globulins that are present in our plasma can be alpha 1, alpha 2, beta or gamma globulins. Now, out of all these globulins that are present in the plasma, the antibodies belong to the gamma type. Hence, if we want to precisely tell what antibodies are, we have to say that antibodies are globular proteins that belong to a special class known as gamma globulins. Right? Alright, so now that we know what antibodies are precisely, let's move on. So the next question is, who makes antibodies? And the simple answer for this question is B lymphocytes. Now, B lymphocytes are special cells that belong to the adaptive immune system, and these cells are specialized in making antibodies. Actually, the B cells themselves do not make a lot of antibodies, but they differentiate into a special cell known as plasma cell, and the sole job of the plasma cell is to generate a ton of antibodies. So if somebody asks us who makes antibodies, the correct answer would be plasma cells, because B lymphocytes, although it is correct, but B lymphocytes need to convert themselves to plasma cells in order to make a lot of antibodies. Now, there are two different kinds of antibodies present in our body. The first kind is known as a soluble form of antibody. These soluble antibodies are secreted into the plasma and tissue fluids. Whereas the other type of antibodies, known as membrane-bound antibodies, they are attached to the surface of these B cells and sometimes are also known as B cell receptors. Alright? Okay. Now, why are they made? They are made in response to an invading antigen. So whenever an invading antigen, a foreign substance, enters our body, the B lymphocytes start making certain antibodies. However, there are certain type of antibodies that do not require our body to be exposed to an antigen. Such type of antibodies are known as natural antibodies. These natural antibodies, they are made against glycosylated cell surface proteins. Right? But these glycosylated cell surface proteins have to belong to an organism that is not like us. Hence, they are made against gut microflora. Specifically, these antibodies are targeted against a disaccharide known as galactose alpha-1,3 galactose. So it's a disaccharide made up of two galactose monosaccharide units, and it is made against the gut microflora. Okay, so these are the only kind of antibodies that do not require the exposure of an antigen. The next important questions that we might have is, what do antibodies do? So antibodies perform 4 basic tasks. Let's see one by one what these tasks are. The first task is they prevent the attachment of microbes to the mucosal surface of the host. So whenever a foreign microorganism enters our body, the antibodies will prevent the attachment of this microbe to the mucosal surface. The next thing that they do is they reduce the virulence of the microbes by neutralizing the toxins and viruses. So as you can see here, there are a ton of viral particles right here. These viral particles are attacked by the antibodies and rendered completely neutral, and now they cannot bind to the receptors present on the host cell. Hence, we are spared from the ill effects of these toxins or these viruses. Right? So that's the second job that antibodies do. The third job that they do is they facilitate phagocytosis by opsonization of microbes. Now what opsonization is? Opsonization is coating of a microorganism by a specific antibody. So whenever a microorganism comes into our body, and if there is an antibody against that microbe, the antibody will coat the surface of the microbe with itself, and it will facilitate the phagocytosis of this coated or opsonized invader by any multitude of phagocytic cells. We have got a ton of phagocytic cells such as monocytes, such as macrophages, such as neutrophils, so on and so forth. So the antibodies facilitate the opsonization and hence phagocytosis of these microbes. And the last thing that antibodies do, and do very well, is that they activate the classical complement pathway. Now we'll have a separate video on complement pathways altogether, but for now just remember that a complement pathway is a set of proteins that attack the membrane of an invading microorganisms and make holes in the membrane, right, and effectively kill the microorganism, right? So in order to activate that cascade of events, antibodies are essential. So antibodies initiate that cascade of events that leads to the lysis of cell membrane of the invading microorganisms and hence renders them. Now that we know what an antibody is and how it works, it's time to see what antibody looks like. So chemically speaking, antibodies are glycoproteins. That means they are proteins with small amount of carbohydrates attached to them. If we take a look at the shape of the antibodies, we'll find that it looks like the English letter Y. It is made up of 4 polypeptide chains. 2 identical longer chains are called heavy chains, while 2 identical smaller chains are known as light chains. These chains are held together by a variety of bonds, including disulfide bonds, hydrogen bonds, and salt linkages. Basically, an antibody is a heterodimer of 2 identical heavy chains and 2 identical light chains. With that information, let us discuss a little bit more about the structure of the antibody and some common terms associated with the antibody descriptions. The first term that we commonly encounter is Fab domain. Now Fab domain is the part of the antibody that is responsible for binding with the antigen. It is this part, okay? This part of the antibody is known as the Fab domain or Fab fragment. This fragment directly attaches itself to the antigen. Now within the Fab domain as well, there is a region about 5 to 10 amino acid long known as the hypervariable region. Now this region is responsible for giving high amount of specificity to a given antibody. Alright, so the next term that we commonly encounter are paratope and epitope. A paratope is actually the part of the antibody that binds to an antigen, and an epitope is the part of the antigen that binds to the antibody. The next common term is Fc domain. Now Fc domain stands for fragment crystallizable domain, and it is this part. Now the Fc domain is actually an important part of the antibody, and it is responsible for binding of the antibody to a receptor It is also responsible for complement activation. However, it is not important for binding of the antigen to the antibody, right? So antigen binding is only carried out by the Fab fragment. That's why you've seen a lot of drugs are actually just the Fab fragments, because there is no need for this region, right? So only this much region is required. So that is known as a Fab fragment of an antibody. Now, depending on the different kinds of the FC domains, we have categorized antibodies into 5 different categories, and they are IgG, IgM, IgA, IgE, and IgT. Now, there are 5 different types of heavy chain domains or FC domains, and they are gamma, mu, alpha, epsilon, and delta. And which heavy chain domain is present in an antibody decides whether that antibody is IgG, IgM, IgA, IgE, or IgD. Got it? Now, IgG is the most varied antibody, having 4 subclasses, as we'll see as we move on. Whereas IgA has 2 subclasses, but others, they do not have any further subclasses. So the next question that we have is, how are antibodies synthesized? So antibodies are synthesized in a polyribosomes, with heavy and light chains being synthesized separately. It is only the heavy chains that are glycosylated. The light chains are never glycosylated at all. Now, it is also interesting to note that the amount of heavy and light chains that are synthesized in a cell are approximately equal, so that there is no leftover of heavy or light chains either. However, the light chains can be secreted out, but the heavy chains are never secreted out of the cell. The IgA and IgM are polymeric antibodies, as we'll see ahead. So they not only contain the heavy chains and light chains, but they also contain an additional chain known as a J chain or a linker chain in between. Now, as you can see here, the J chain actually holds the 2 monomers together. This is a molecule of IgA, by the way. Alright, so now with all these questions answered, let us take a closer look at each and every category of the antibody, and let's take a look at some important features of these antibodies. So let's start with IgG. Here is the pictorial representation of IgG along with other antibodies. Now, IgG is a very special antibody for a multitude of reasons. Let's take a closer look at some of the features that make IgG stand out. IgG is one of the most abundant antibodies in the serum. About 80% of all antibodies present in the serum belong to the IgG class. It is also the lightest antibody present in the serum. That means the molecular mass of IgG is the smallest compared to all other antibodies present. Also, it is present only in the monomeric form. It is not present in polymeric form at all. It is also the least glycosylated antibody that is present in plasma. That means it is not having as much carbohydrate content as some other antibody classes, right? It contains about roughly 3% carbohydrates in it. Now, IgG is also important because the half-life of IgG is the longest at 23 days. So once IgG is synthesized in the body, it can stay in the body for a very long period of time, up to about 23 days. The next longest lasting or longest circulating antibody is about 8 days. So you can see how IgG is leaps and bounds ahead of the rest of them in terms of circulation half-life. Other important fact is that IgG contains 4 different subclasses: Ig1, Ig2, Ig3, and Ig4. And out of these 4 subclasses, only Ig2 cannot pass the blood placenta barrier. The rest of them can easily cross the blood placenta barrier. Hence, IgG is the only antibody that a mother can give to her fetus, right? But IgG2 cannot transfer. IgG1, 3, and 4 can transfer. Another important thing about IgG is that it is a very potent activator of the complement pathway. IgG3, in fact, is one of the most potent activator of the classic complement pathway, with Ig1 and Ig2 also having some capability, but not as much as Ig3. Ig1 and Ig3, they bind to the Fc receptors of the phagocytes, and hence they are quite good for opsonization as well. So a lot of opsonization will be done by IgGs as well. As a matter of fact, IgG is one of the first antibodies to be released once we have an infection. It's not the first antibody to release is IgM, but it is obviously the second antibody that is released. But it lasts in the serum for a longer period of time compared to IgM. Now, about the location of IgG, IgG is equally found in intravascular compartments as well as extravascular compartments. So you'll see IgG in the blood and in the tissues as well. So IgG is one of the most important antibodies that we have. The next class of antibodies is IgM. Now, IgM might not be as widely distributed in the serum as IgG was, with a serum share of about 5 to 8%, but it is one of the heaviest antibodies that we have. Weighing in at about 900 kilodaltons on an average, IgM is always present in a pentameric form. Now, being in a pentameric form is advantageous to IgM as it can bind to more than one antigen at a given time. Technically, IgM can bind to 10 antigens at a given time, but because of steric hindrance, about 5 antigens can be bound at the same time to IgM. Another interesting thing about IgM is that it is heavily glycosylated with about 12% carbohydrates in its structure. IgM also is quite significantly less circulating compared to IgG with a T-half of about just 5 days. There are two subclasses of IgM, IgM1 and IgM2. And one of the most important parts or aspects of IgM is the fact that it can very efficiently activate the complement pathway. Now, IgM is one of the first antibodies that is produced as a primary response to any antigen. So whenever an antigen comes to our body, IgM is the first antibody that is produced. It is also the first antibody that is synthesized in neonates as well. Now, IgM is present on the surface of B cells and also it is secreted in the plasma. However, there is one important thing to note here. When IgM is present on the surface of B cells, it is exclusively present as a monomer, but when it is secreted in plasma, it is exclusively secreted as a pentamer. Alright? Okay, so this was an important part about IgM. Now let's move on and take a look at IgA. With a serum distribution of about 10 to 15%, IgA is the second most abundant antibody in the serum. Now, the molecular mass of IgA is about 160 kilodaltons and it is present in a dimeric form. It is also heavily glycosylated at about 8% carbohydrates in its structure. However, the most fascinating thing about IgA is the fact that it is present in two forms: serum IgA and secretory IgA. The serum IgA is exclusively monomeric while the secretory IgA is dimeric. Secretory IgA, as a matter of fact, is the most commonly produced antibody of the blood. Now, the secreted IgA is secreted along the mucous membranes and it is one of the only antibodies to be secreted in any sort of bodily fluid. Now, also is special because it activates alternate complement pathway. The rest of them were activating the classical complement pathway. This one activates the alternate complement pathway. So this is also very interesting fact to note. Also, IgA is the only immunoglobulin that is present in breast milk. So when the baby or an infant is not producing its own immunoglobulins, the mother can provide a small amount of IgA through the breast milk. Alright, so that's it about IgA. Let's move on. The next antibody is IgE. It has a special distinction of being the lowest circulating immunoglobulin in the serum with a concentration of less than 1%, far less than 1% in serum. The molecular mass is about 190 kilodalton and it always exists in a monomeric form. The half-life about 1 to 5 days is average compared to other antibodies as well. It is the only antibody in serum that is heat labile. That means at 56 degrees centigrade, the IgE completely inactivates while IgG, M, A and D still remain quite active. So it is the only heat labile antibody that we have. The other important fact to note is that IgE is sometimes known as a reagenic antibody as it precipitates type 1 hypersensitivity reactions. There'll be a video soon about hypersensitivity reactions, different kinds of hypersensitivity reactions, and we'll talk about the role of IgE there. But for now, just remember that IgE binds to the basophils and mast cells and cause them to degranulate. Degranulate means the mast cells and basophils contain a lot of granules that contain inflammatory molecules, and IgE, after binding to these cells, lets these molecules loose and hence can cause a high amount of inflammation and anaphylactic shock as well. IgE is also supposed to have a role in killing parasitic worms, right, such as leishmania and stuff like that. Other important thing is that IgE is the only antibody that contains 3 constant domains in the Fc region, whereas the rest of them contain 2 constant regions in the Fc domains. Just take a look here. You can see that there are 3 constant domains here, 1, 2 and 3, which were 2 in IgG, 2 in IgD, 2 in IgA and 2 in IgM. So this is kind of a special feature of IgE as well. The last immunoglobulin that we have to discuss today is IgD. Now IgD holds a special distinction of being the second lowest circulating immunoglobulin with less than 1% in concentration in serum. It has a molecular mass of about 180 kilodaltons and is always present in a monomeric form. Now with a half-life of about 2 to 8 days, IgD is having an average half-life compared to other antibodies. It's neither too long nor too short. Now, one of the most important thing about IgD is the fact that it is the highest glycosylated antibody that is there. About 13% of carbohydrates are present in one molecule of IgD. It is present on the surface of B cells and acts as an antigen recognizing antibody. It is the concentration in plasma is so low that we really don't know what it does in the plasma as such. It cannot activate the complement, and we still really don't know what the role of IgD is in the overall response to the pathogens. So that's it guys, we'll stop right here for today. I hope you learned something new. If you happen to like the video, please don't hesitate and smash that like button. If you want, you can share the video with as many people as you can. And if you have any suggestions, please feel absolutely free to comment in the comment section below. And also, please don't forget to subscribe. Bye.